Okay, guys, good evening. So, for today, I'll be taking you on two's complement. Okay, so let's see how to digest, to break down, to solve equations or questions that regards two's complement. Okay, now I'll be solving, and in the course of the solving, I'll give you some steps, some hints that will help you. That without my guidance, supervision, you can easily solve yours. Okay, so go through the steps. Go through the steps in order to be able to get what I'm saying today. Okay, thank you so much. Thumbs up. So, what then is two's complement? Two's complement is simply a method used in representing a negative number in binary state. Okay, you use two's complement to represent any given number or binary number in its binary state. Okay, a negative number. Don't forget a negative number. So two's complement really work more with negative numbers, right? Okay, so let's see how to go about it. In solving two's complement, number one step is, first and foremost, find the ones complement of that number by inverting the given binary number. Okay, you find the ones complement of a given binary function or number. Okay, by invert, should I say negating? Okay, negating that number. Okay, so meaning by negation, I means if the value is 101, by negation it should be 010. Okay, that's negation. That's how to find the ones complement. After which, you now find you add 1 to the derived ones complement. You add 1 to the derived ones complement. Now the result becomes the two complement state of the given number. And also, don't forget that in binary status, we say that generally it is generally accepted. We say that any function that begins the most significant number being 0, automatically that number in its binary state is a positive number. Now, any number in the binary function that represents 1 at the far left, that number being 1 at the far left, that number becomes what we call a negative number. So when 1 represents or begins a binary function, that number automatically becomes a negative number. And when 0 begins a binary function, that number automatically becomes a positive number. So when you see a 1, you need to change it. It means that number is in its negative form. Okay? But when you see a 0 as the beginning form of a binary function, it means that number needs to be converted to the ones complement, or two's complement, sorry. Okay, so let's see how it goes. So let's pick an example. We're going to use a number called, what should I use? 8. 8. This is number 8, right? So 8 is the decimal value. So the binary function of 8, we have, let's use how many bits? 1, 2, 4, and 8. Okay, so we are having 8 bits here. So 8 bits will give us, to get 8, that means 1, 0, 0, 1, 0. Okay, so this is the binary function of 8. But this binary function already, it's represented in a negative state. Why and how? I said earlier on that once the most significant bit, which is this one, is a 1, that means that number is negative. So when it is a 0, that means that number is what? A 1. Okay, so as a result, this number already is in its negative state. 8 is not this is not a positive 8, please. This is a negative 8 automatically. Okay, so we have this, but let's see if you can work with this. Let's see what will happen. Okay, so we're having this now. The rule states convert this man, the binary function, convert it to one's complement. How do you convert it to one's complement? By inverting this number or negating it. That is the right word to use. Okay, so by negating this, I have that if it is 0, if it is 1, sorry, it should give me 0 here. If it is 0, it should give me 1 here. If it is 1, it should give me 0 here, 1. So 0 here, 1. Okay, so this is the ones complement. This is the ones complement of this. Okay, so in solving this again, what I need to do is to add 1 to the ones complement. Add 1 to the ones complement. So by adding 1 to the ones complement, I have that 1 plus 1 gives me 2. But the answer is 10. That is 10 kind of. So you put 0 and carry 1. Put here 1 plus 1 again, 0, carry 1. put here, 1 plus 1 again, 0, carry 1, put here, so that 1 will now come down. Look at it here. So this is the just put your minus sign kind of. This is the negative state of this given number. You see that this one and this one, they are the same. So I say when a number has 1, it is already in its negative state. But when there is 0 already, it is what? A positive number. That's just the idea within that expression. So that is how it goes. Let's consider another example. So we are having 15, right? 15 as the decimal value. So we have to find the binary value of 15. So I'm going to use a 16-bit to prove that. So by using 16-bit, that means this is 0. 8 plus 4 is 12. So this becomes 1 and 1. That means they are considering you can pick them. So 2. So 12 plus 2 gives me this, plus this gives me 1 here. So if you add this together, it should give you 15, right? Okay. So the first step after getting the binary function of it, what's the next step? I said invert the number. By inverting the number or negating the number, it means when it is 0, it should give me what? A 1. When it is 1, it should give me what? A 0, 0, 0, 0. Okay. Is this the right thing? This is just the ones complement. Okay, this is just the ones complement state. So you don't use this man. Okay, complete your rule. Your rule states that after this you should do what? Add 1 to it to give you a 2's complement. So adding 1 to it to give me a 2's complement becomes this plus this is 1. 0 comes down, 0 comes down, 0 comes down, 0. Sorry, 1's come down. So you bring 1 down, 0, 0, 0, and the 0 plus 1 gives me a 1. But this number now, if you add this number, is not 15. This is not 15. This is 16 plus 1 gives me 17, which is not what I was asked to do. So what am I supposed to do again? I need to convert it again by the 2's complement. I need to convert it again. So this will give me a 0, a 1, 1, and 1, and 0. Okay? By converting it, I'm still taking the same thing. The 1's complement is the 1's complement. 1's complement. So after this, you do what? Add 1 to it. So you add 1. By adding 1 to it to give you a 2's complement, this plus this. 0 plus 1 gives me 1. 1 comes down, 1 comes down, 1 comes down, and 0 comes here. But you can recall what I said, that when it is 0, it means the number is positive. So instead of writing it 0, it will float. It will float because it's not needed. So we have, this is 8. This is 8. This thing is under 8. This one is under 4. This one is under 2. This one is under 1. So let's join it together. This plus this gives me 12. 12 plus 2 gives me 14. 14 plus 1 gives me 15. So this one is floating. So you don't need it because it is talking about negative number. Don't forget I was using 16-bit instead of 8-bit. I don't want to use the 8-bit kind of. So this becomes a negative number. This one is floating. That's why it carved out. Okay, so check it very well. So guys, so far you've been able to see at least how to convert a single value to the binary state, and after which you find the 2's complement of the negative number. Don't forget, you are finding the 2's complement for only negative number. Are you good? And also, then everything we're doing should be outlined, right? Okay, so we've seen how to find for the single number. Furthermore, we're going to be seeing something different, okay? But not today. Not today. Some other time when I come your way, we see more on it, okay? So keep practicing to become more better in it. Thank you. God bless you.